Well, hi there, everyone. Welcome to Dome at Home. Hope you're all had a good week since last week. My name is Scott Young. I am the planetarium astronomer at the Manitoba Museum, and I'll be your host for today's program. Dome at Home is all about you at home while you're staying away from people, isolating and staying safe, to go out and look at the stars. We can still do outside activities. We can go outside, we can see the stars, we can find the constellations, and this program is a weekly program that is designed to show you everything that is up there and how you can find all of this stuff. We use the chat window quite extensively. If you're in Zoom, you can use the chat window to ask questions and things like that. If you're on Facebook, you can use the comments thread as well. My colleague Mike is out there, and he's going to be moderating as well as taking care of some of the other details behind the scenes. How you doing, Mike?
Hey, Scott, I'm doing great.
Excellent. So what'd you think of last week's show, the first Dome at Home?
I thought it was fantastic. We had a great audience, lots of questions being posted in the chat. I could barely keep up with most of them.
Exactly. Yeah, we do always get a lot of questions. Based on the phenomenal response from last week, we are extending the show a little bit in terms of length. We're not going to cut it off right at 7:30 because there is a lot of questions that are coming up. We may save some of the questions towards the end. So if you ask a question in the chat or on the comment thread and it doesn't get answered by me or by Mike fairly soon, it's probably because we're saving it to the end of the show, because we're going to try and keep the questions that we answer live relevant to whatever we're talking about right then to keep the flow of the show going. And then if there are some that Mike can answer sort of in the background, he'll do that. And then at the end, we'll stick around and have time to answer questions. We were going to do that on Facebook. Turns out to be easier just to extend the live session to do that. All of you that are out there, we would love to know where you're watching from. We'd love to know how many people are watching. That's the kind of thing that our funders and sponsors like to know, how many people we're reaching. And of course, we like to know as well. Astronomy is a worldwide activity, so it's great to know where we have folks from. Oh, we've got Ethan and Jackson from Thompson, Winnipeg, of course, a number of people from Winnipeg. Oh, folks from Edmonton, nice. And somebody from just down my street. That's awesome. Good stuff. So yeah, let us know. We love to know how many people. Man, there's a lot of people in the chat. Stuff is just flying through. This is great. Okay, let's get right into things this week. We are going to be focusing on the moon as our sort of highlight topic today, but every show of Dome at Home includes a little bit of sort of what's up in the sky and what you can look at. The idea is, if it's clear after the show, you can put on your jacket, go right outside and find this stuff in the sky. If it's not clear, you can go tomorrow or the next night or the next night. Basically, we cover sort of a week at a time, because with the exception of the moon, not much in the sky will change during that week. You can go outside. There are star maps available on the Manitoba Museum webpage, which is manitobamuseum.ca/dome at home. Mike will drop that into the chat windows and the comment threads and things like that. So you can always download star maps and activities and things like that as well. All right, let us see here. One of the things that I always like to sort of start off with is a little discussion about one of my heroes here, Dr. Helen Sawyer-Hogg. Pioneering Canadian astronomer. Her career spanned 5 decades. She did a huge amount of amazing scientific research. She was one of the pioneering women astronomers in Canada as well. She also did a lot of astronomy outreach. She felt very passionately that, as she would say, the stars belong to everyone. This is your and my birthright. These stars have been here since before people were here, and they'll be here long after we're gone and we pass them down to the next generation. So understanding them is kind of important, certainly was to Dr. Hogg. And she was kind of one of the inspirations for this show. So the stars belong to everyone is really sort of our theme for what's up there in the sky, making sure that you can go out and find those stars that belong to you. Okay, we're just going to see if we can move on here. So if you go outside tonight, well, here in Winnipeg, it's totally overcast and we're going to get snow. But depending on where you are, it may be clear. If you go out around 7 o'clock local time, that will basically give you a view kind of like this. We're facing towards the north. Last week, we covered some of the northern sky. We covered things like the Big Dipper, which is the group of 7 stars over in the north right now. Nobody uses dippers anymore, but it's kind of like a frying pan with a handle. We know that the Big Dipper can be used to find that really important star, the North Star, we covered last time. The 2 pointer stars, the ones right at the ends of the bowl there, they point right at the North Star. It's not the brightest star in the sky. It's not very conspicuous, actually. So it's nice to have those pointer stars to be able to locate it. So the North Star, always directly due north. And so if you find the North Star, you can actually do a lot of celestial navigation, navigating by the stars, just by knowing where that one star is. You can even work out where your latitude, all sorts of things like that. So the North Star is in the handle of the Little Dipper. We know that many of you are watching from inside a city, or at least in the suburbs, and not everybody has a nice dark sky to look at. So the Little Dipper is pretty hard to see from inside the city. I have to say, I don't think I've ever seen those middle stars in the handle there. I see the North Star from my backyard in suburbia, and I see the 2 at the end of the bowl, but the ones in the middle, you just can't see them. Okay, let's move on to another area of the sky here. Oh, there's our labels. They didn't come up on time. We also talked about a constellation, Cassiopeia, last week. Cassiopeia is high overhead at this time of the year at around 7 o'clock. If you look almost straight up, you'll see Cassiopeia. If you're facing towards the north, where you were just with the Big Dipper, you've got Polaris there. If you keep that line going, you come to Cassiopeia. It kind of looks like the letter M that somebody sat on. So it's definitely a different kind of constellation than the Big Dipper. It doesn't really look like what it's named after, because Cassiopeia is supposed to be a queen. We heard a little bit about the legend of Cassiopeia last week, how she was very vain and she would be bragging about her beauty, and she offended the mermaids that are the daughters of King Neptune. If you ever saw the Little Mermaid movie, you pretty much know all about those folks. Cassiopeia got into trouble with them, and we'll hear the second part of that legend just a little bit later on in the evening. So remember Cassiopeia, we'll get back to her. Let's move on to the south. Right now, the southern sky does not have a lot of bright stars. In fact, there's only one really bright star, and it's very high up. It's almost 2/3 of the way up the sky. So if looking at the horizon is 90 degrees or 0 degrees, and looking straight up is 90 degrees. This would be around 60-degree angle up towards the south. That is not a star, though. That is actually a planet. That is the red planet Mars. And so taking a look at Mars, we've been watching that for months now, and it's still very, very bright in that portion of the sky. Let's just see if we can get our... There we go. Poor imagery is going a little bit slow today. I'm not quite sure why. That's okay. We got it all working. Mars, the red planets, it's the only planet that we can easily see in the evening right now. If you're very, very conscientious about observing, you might get out right after sunset and you might still be able to see Jupiter down in the west. And next week, we're going to talk about the planet Mercury. But right now, Mars is pretty much it. And it's already past its best appearance. It's really something that is on the way out for this season. But still, nice to see. And Mars is going to be big in the news over the next month or so as we send more robot spacecraft to explore it. Okay, now looking over into the western sky, not everybody has a panoramic view, so we try and give a little bit in each direction depending on which way your balcony faces or your window if you're in an apartment. Off in the western sky, we have a couple of fairly bright constellations. The one that sort of looks like a big cross is called Cygnus the Swan, and the other one that looks kind of like a little fish is called Lyra the Harp. Those are part of the summer triangle. Now, I know it's kind of ridiculous that here it is January, we can still see 2/3 of the summer triangle. Astronomers are terrible at naming things. They will name something and it just won't apply for whatever reason. So it's a little bit confusing, but you can still see those things there. And I mean, with our relatively warm weather, it does feel still a little bit like summer. Okay, and then off in the eastern sky, the east is where the new stuff starts happening. As the year changes, the new constellations for the season become visible in the east. And in the eastern sky right now, we have a lot of those winter constellations. Probably the most famous one, Orion the Hunter. We'll be featuring Orion a little bit later in the year. There we go. Orion has a belt of 3 stars around his middle. Very, very distinctive. You will not find 3 stars that bright, that close together anywhere else in the sky. So it really stands out. And then, of course, he's got 2 stars up at the top for his shoulders, and then 2 stars down at the bottom for his legs. We'll get into Orion and some of these other winter constellations a little bit later as we go through. We have this series is running at least through the end of March, and so we'll have lots of time to get into all these constellations. Captions are very slow. Okay, so one of the things that does change in the sky fairly rapidly, and this is why we sort of devoted a whole show to it, is the moon. The moon is one of the more fickle things in the sky. It doesn't just appear in one spot and then you can go out the next night and see it. It doesn't look the same every time. We just passed new moon on the 12th. And new moon is when the moon is basically not visible at all. But then a couple of nights after new moon, it starts to appear in the western sky after sunset. And so here, this is basically the view on the 16th. And so that is basically why, the area of sky we can see it in right now. I'm just going to move the chat window down a little bit because they're going by so quickly. There's so much discussion going on that it was hard for me to stay on target here. Okay, looking at the moon on the 16th, there'll be a very, very thin crescent. So what we've got here, we've got a little white dot where the moon will actually be in the sky. And then beside it, we have sort of a magnified view of what the moon will actually look like. That's on the 16th. The 17th, the moon will move to another spot. And it's really, really acting very slow here. So the moon from one night to the next moves quite a distance of about, 15 degrees or so. What does that mean? Well, if you take your fist and you hold it out at arm's length, that width in the sky, that's about how far the moon will move in one night to the other. Now that's the motion from night to night. Of course, the moon and everything else in the sky is still rising and setting, moving across the sky. So there's these 2 motions on top of each other. And that's why the moon was a little bit more sort of confusing, I would say. So on the 18th, we wind up here and you can see the crescent moon is growing bigger and bigger. On the 19th, more of a crescent, getting towards sort of a half moon and getting higher in the sky. These are all at 7 o'clock. So each night, if you go out, you'll see the moon higher and higher and more illuminated. And then as we get to the 20th, we start getting close to the moon being very near Mars. So what's going on here? What is happening to create all of these changes? Well, it's fairly straightforward. The moon is just basically a big rock in space. It doesn't give off any of its own light. If the sun wasn't shining on it, it would be totally dark and you would never see it. But luckily we have a sun, and that sun lights up the whole solar system really, and it lights up the moon as well. And so here we have what the moon does over the course of an entire month. It goes through what are called its phases. And so you have a new moon when it's completely invisible. It's still there, you just can't see it because none of it's lit up, that's facing towards us. And then you start getting the crescent phase, looks like a toenail clipping or a banana peel or a banana or something like that. You get first quarter like that. You wind up with a gibbous moon. Gibbous is like more than half, less than full. Then you have full moon. That takes about 2 weeks. And then the whole thing reverses itself the other way for another 2 weeks. So about 4 weeks or so is what it takes the moon to go through its cycle of phases. It's no coincidence that that is about a month. That's where month comes from. Month is essentially moon when they were coming up with the idea for the calendars. So using the moon and the motions of it and the phases of it has been part of our history for thousands and thousands of years. And there are still many cultures that still use a lunar-based calendar rather than the one that is based on the Earth going around the sun. Because while the Earth going around the sun is useful as well, it's harder to observe compared to observing the phases of the moon, which are very easily seen by pretty much anyone. You don't need specialized knowledge or specialized equipment or anything like that. When it's full moon, you can figure it out. So the moon is this rock in space, and it is the closest thing to us celestially speaking. The only things that are closer than the moon are the occasional asteroid that goes whizzing by. We'll not worry about those right now. And anything else is probably a spacecraft that we built and put up into orbit around the Earth. Between us and the moon, 380,000 kilometers or so, nothing else. And that's the closest thing to us. If you look at the moon close up, though, it's not just a sphere with some light and dark patches. It is rocky, rough, mountainous terrain covered with craters. Craters are all these round holes that are stuck in the surface of the moon. They're caused when huge asteroids or comets or rocks from space, that kind of thing, smash into the moon, explode, and leave this gigantic scar. The moon has been pounded for a very long time. It is totally covered with craters. There's no water on the moon. There's no air on the moon. There's no erosion or volcanoes or glaciers to change the surface. There's no plants to cover things up. So the craters, they just stay there pretty much forever. The only thing that wears down craters is other asteroids crashing on top of them, making new craters. So the moon is basically a record of the last 4.5 billion years of the solar system's bombardment history, if you want to think about that. All these things crashing into planets, we can't really watch them on the Earth, and we haven't been around for 4 billion years, but on the moon, it's all perfectly recorded. So that's one of the reasons to actually go to the moon. Okay, we're not going to go to the moon today, of course. None of us have that capability quite yet, but the moon is going to be visible in the sky for this whole next week. And so we're going to talk a little bit about some of the ways that we can observe the moon and things that we can do in terms of activities. One of the things that I like doing when I go outside is I like to record what I see. One of the most important tools for an astronomer is a pencil, because it's amazing how quickly you forget stuff, or it's amazing how it turns out maybe you see a bright meteor, but you didn't write down the time or date, and so that information doesn't help. So what I like to do is, just grab my book here. If you want to do astronomy, get yourself some kind of book. I grabbed one from the dollar store. It's just a sort of a hardbound scribbler kind of thing. You don't want to use loose paper, because loose paper disappears really easily. Get something where the paper is in. It can be a scribbler, it can be anything like this, and a pencil. And basically, you can record all your stuff in there. I haven't done as much recently, but here's a drawing of a comet that I made one time. And every time I look at this book and I look at that drawing, it's a terrible drawing. I mean, I'm not an artist at all, but it reminds me that time that I was out and I saw this beautiful comet. So every time I look at this, it's like having a picture, really. Even though the picture itself is not very good, it triggers that memory. The other great thing about a logbook or any kind of diary is when you're writing it down, you really think about it. It sort of puts you under pressure to try and really be careful in what you're looking at. It really helps your observing. So your eyes look a little bit harder and your brain thinks a little bit harder because you know you're writing it down. So I highly recommend getting yourself an astronomy logbook. You can use it for just astronomy, or you can mix it up with a bunch of other things. But the idea is to record your observations. Galileo did that about 400 years ago, and his observations are now, of course, priceless treasures because he made some amazing discoveries. You can make those discoveries too. It doesn't matter that Galileo beat you to it by 400 years. You'll still make those discoveries, and it'll be really good to have a record of that. Okay, before we move on, one of the things that we talked about last week was a way to try and get the city lights out of your eyes. And, not all of us have the ability to just get out of the city or even to be in a backyard or something like that. You might have to observe from your window or apartment balcony or a parking lot where there's lights around. And so we came up with these light shields. This is just a cereal box that has been painted. Actually, both of my girls did some great decoration of them. We just painted them on the outside so that we didn't get in trouble for showing you what brand of cereal that we have, because copyright. But then we just decorated them with stars, and they basically work. You hold them like binoculars, but they don't make anything come closer to you, but they block out all the lights coming from all different directions, and it helps you see just the stars. So these actually work really well. I'm surprised that I haven't heard more about these. I'd like to think I've invented them, but I'm sure other people have in the past. But anyway, this works really well for finding stuff in the city sky. If you make one based on our conversation last week or this week, we'd love to see how you decorate yours. So if you take pictures, you can send them into space@manitobamuseum.ca. That's our brand new email. Should be easy to remember. The word space, SPACE. And send us pictures of the astronomy tools or your logbook or things like that. Show us what you use to observe the sky. We'd love to see that. And it lets us know that that people are paying attention and are interested in the ideas that we're putting out there. Okay, I'm going to take another look at the chat here just to see how things are going. Mike, you got any questions in there that are sort of coming up, or how's the?
Oh, are you kidding me? I can't even keep up with the questions that are coming in here. Lots of great questions about the moon. Here's one that I actually really couldn't answer, Scott, so maybe you can. If we were on the moon, would the Earth rise from the east and set in the west? I think I know the answer, but I'm throwing it back to you.
That's a great question. You're trying to catch me out because I'm going to have to derive it from first principles myself. I have to think about it. The great thing about the moon is that it pretty much keeps one face towards the Earth all the time. So that pretty much means that the moon doesn't really rise or set. It would just pretty much stay in one spot in your sky. Now, some of the time, the Earth would be in your daytime sky on the moon, and some of the time, the Earth would be in your nighttime sky on the moon. But it wouldn't really move all that much. It does wiggle around a little bit. I don't know if you remember the moon phasing thing here. You see the moon phase is not just phasing, but it's wiggling and rotating a little bit. The Earth would do the same kind of thing over the period of a month or so. I think that's right. Is that what you were going to say, Mike?
That is what I was thinking. Yeah, because we always have the same side of the moon facing towards us, which means that if you are on the moon looking towards Earth, it shouldn't be rising or setting. So that was my suspicion, but I wanted to throw it to you just to see if it would confirm it.
Excellent. Well, confirmation bias. That's perfect. We convinced each other that we're correct. I'm almost certainly going to run this through my computer simulator tonight after the show just to make sure that I got it right there. But it's really interesting. The great thing about astronomy nowadays, I mean, we know quite a bit about astronomy, but even what we don't know, you can find out really easily. I mean, obviously the internet, there are apps that you can download that you can just hold up your phone and it'll tell you which planet is which and where they are and stuff like that. There's a free set of software called Stellarium. That's what we made these star charts with that we were showing, that basically allows you to set up the sky on your computer at any point and take a look at where the moon's going to be or all those kinds of things. So there's a lot of really good resources. You don't need a telescope necessarily. Those can be fairly expensive, and right now they're pretty hard to get actually. But all you need is a little bit of interest and going out into the sky, under the sky, and checking things out. Okay, let us just take a look here. One of the things that we like to do in astronomy is to make models. Models help us understand how things work, because you can't just go into a lab and mix up a batch of stars in a test tube and see what happens. You can't make a bunch of planets and hit them with asteroids and see what happens. All we can really do is observe things and then try and figure out what's causing that. So astronomers make a lot of models. So we have like the globe, you know, the Earth spinning around with the stand that holds it in place. And we often make scale models to try and relate how big things are or so on. So since this week is the moon, I thought we'd make a little moon model. All you need is a styrofoam ball or a rubber ball, a tennis ball, something like that. I'm actually going to still use the same orange that I had from last week. I left it down here on the desk and it hasn't gone bad yet. This is going to be our moon model, and this is going to be our Earth model. Your head basically is the Earth. And so pretty much the simple thing that happens is the moon just orbits around the Earth, and it sort of goes around, oops, I'm getting out of frame here. There we go. And it goes around like this. And it takes about a month or so to come back to the same spot. Now, how far, if we're going to make this model the right scale, how far is the moon from the Earth? Is it like right close, or is it sort of like this far away, or is it this far away? Like how far would you have to put it? It turns out your arm's not long enough. You pretty much have to have about 4 arms worth of distance between you and the moon to be able to set this up at the right scale. And that's something that it always blows my mind, how big the distances are between things. The moon is the closest thing to us, the closest thing in space, and it's 380,000 kilometers away. It's actually far enough away that even a radio signal, if we were talking to someone in a spacecraft, would take 1.5 seconds to get all the way there, and then 1.5 seconds to get all the way back. So it's quite a distance. That's why we can't quite just, you know, pop over there yet. But we do have some things coming up that will actually allow us to explore the moon. First of all, there's all these robotic spacecraft that have been there, and it's just an amazing time to look at the moon and, you know, see these craters up close. It is a stunning sight. If you get the chance to use binoculars on the moon, they're like 2 little telescopes, one for each eye. If you have them, take a look at the moon, and it's like being in a spacecraft on the way there. You can see the craters, you can see the dark areas that are basically flat areas covered with lava. You can see the bumps and things like that. And especially right where the dark and light area is, the shadows, you can have this amazing view through those binoculars. We will be doing some telescope viewing of the moon on other nights when it's clear. So one of the good ways to keep in touch is to register for Dome at Home. Even if you're watching us on social media, excuse me, if you register on the Manitoba Museum's webpage, you can register for our Zoom webinar. That way you get in on the chat here. There's a lot of conversation going here on the Zoom chat, lots of questions and things like that. You'll also get notifications on when we go live, reminders of when the shows are, and you'll also get information on when we're going to do telescopes and things like that. So definitely worth registering. And we're sort of building a new community here. It's not really a club, but it's a group of people that are all interested in the sky, and we're sharing ideas and stories. And we'd like to have a sort of a place to do that. So if you're interested, register, subscribe, click on like for the Manitoba Museum's Facebook page, and that'll be a good way to stay in touch and stay connected with all the things we're going to be doing. Okay, let me get back to our, there we go. Let's go back to the moon. Literally, in fact. You've probably heard in the past that humans went to the moon. Yes, they did. Don't go there. The Apollo astronauts went all the way to the moon, landed there, walked around, picked up rocks. It was not faked. We're not even going to get into that. But it was one of the most impressive scientific achievements. And it might have happened because of, you know, Cold War tensions and political maneuverings and things like that. But we went because we decided to go. And that's the way humans solve complicated problems. We decide we're going to solve it, and we do it. It's it kind of makes you hopeful for the future. Well, one of the things that's happening in the next little while is humans are going to go back to the moon. not because it's a rerun or been there, done that kind of thing. It's actually really valuable because if we want to go on to other places, to Mars, I saw someone in the chat. If someone if someone wants to go to Mars, learning the skills that we need at the moon is a really good idea. The moon is only 380,000 kilometers away. Mars is like 55 million kilometers away at its closest. So it's kind of nice to practice in your backyard before you go all the way across the solar system. That's what the Artemis program is all about. It's a program that NASA announced to go back to the moon. Their goal is to send the first woman and next man to the moon. So obviously trying to get some gender equality there for once, which is nice. The Artemis mission, the first launch is supposed to happen this year, 2021. It'll be an uncrewed, so no one on board, just a test flight of the rocket and the capsule, and it'll basically go around the moon and come back, just to make sure everything works and nothing blows up. Artemis 2 will do the same thing with astronauts on board. 4 humans will go out, loop around the moon, and come back. Just last month, it was confirmed that one of those 4 astronauts will be from Canada. We have a great agreement with the NASA, with the American space program, and many other countries. And even though they're building the rockets and they're building the spacecraft and things like that, Canada is contributing personnel and expertise. We're going to be building a Canadarm version, Canadarm3, which will go on to the Lunar Gateway space station that's going to get built as well as part of this program. And part of our payment for that is we get to send a Canadian around the moon. So that's pretty exciting. The current schedule is 2023. A Canadian astronaut will go all the way around the moon, a 10-day flight, basically very similar to the Apollo 8 flight that happened in 1969 or 68, pardon me. That was a landmark mission for the human species. That was the farthest someone had ever gone, and it changed the way we looked at everything. So having a Canadian on board a mission of that kind of magnitude is pretty exciting. It's going to be one of these 4 people. We have 4 active Canadian astronauts. A lot of the folks that you might know, Chris Hadfield and Julie Payette and folks like that, have all retired from the astronaut corps. They have other gigs right now. But we have Jeremy Hansen, we have Jenny Sidey-Gibbons, Josh Kutrick, and David Sejac. David has been on the space station already. The other 3 have not flown yet. The most senior one of the folks who have not flown yet is Jeremy Hansen. And we had the pleasure of entertaining him at the Manitoba Museum just a few years ago, back in the before times. And super nice guy, really competent, really friendly, down-to-earth kind of guy. I'd love to see him go around the moon. But to be honest, any Canadian astronaut going would be really exciting, because when a Canadian goes, we all go, basically. We get to ride along and see the live pictures and feel that we're participating in this amazing journey going off to the moon. So pretty exciting news. Now the bad news. We have no idea whether this is going to happen on schedule. The mission plan is very ambitious. It is very complicated, very expensive, and it was also promised back in a time when a different president was there. That president, whose name we will not speak, will not be around much longer, and so we'll have to see if this is a priority of the new administration. Whenever there's a change in politics, things like this can get delayed. Still, really, really cool. A Canadian going there. Actually, we know that 2 Canadians will be part of the Artemis mission. We have 2 seats. They've announced this is the first one. What's the second seat going to be? I hope it won't be a loop around the moon. I hope it will be land on the moon, walk around, pick up rocks. That's going to be pretty cool. That's the kind of exploration that got a whole generation excited back in the 60s. If you're old enough to remember the Apollo missions, basically the kids that saw that got excited about science and engineering and went on to invent the iPhone and the computer and so much of the technology that we're using today was basically envisioned and invented by people that were inspired by Apollo. So even if, you know, this happens a few years down the road, I really hope it'll have that same kind of same kind of, what's the word, inspirational value. So sorry, I did have to mention politics there briefly, just because it impacts directly on NASA. This is not a political thing, and so I'll ask you to keep your political posts off, please. We're going to focus. The great thing about astronomy is that when you're looking up, all these earthly concerns really just sort of fade away into the background. They're not nearly as big of a deal when you're starting to contemplate the entire cosmos. So let's get it back to our images here. So one of the things that we've talked about previously was, let me just see here. There we go. One of the things we talked about previously was Queen Cassiopeia, if you recall. Good old Cassiopeia was the queen who decided that she was more beautiful than the nymphs of the sea, and she offended King Neptune. Well, Queen Cassiopeia was married to a guy by the name of King Cepheus. And Cepheus is another constellation up there in the sky. We'll get to him shortly. He didn't really know what to do about his wife's boasting. I mean, he was kind of used to it, I guess, and, you know, didn't really see it as a major problem. But it certainly started having an impact when she started boasting and causing these problems. But he still didn't really deal with it. So he sort of just, you know, put it off. Well, then what happened is poor Cassiopeia continued to have these boasting sessions. Finally, King Neptune said, okay, if you don't stop it, I'm going to cause some trouble for you. And he sent a giant sea monster named Cetus. And Cetus was basically a huge monster that came and started ravaging the countryside. And at this point, poor King Cepheus had to get involved. He couldn't ignore this anymore because his kingdom was getting destroyed, essentially. And so it makes it very difficult to ignore when all of this is happening. So finally, he had to talk to his wife, and they had to agree to stop her boasting. But that wasn't good enough for King Neptune. Neptune really felt that he was, you know, he was going to deal with this situation, set an example. And, you know, a lot of these constellation myths, they're based in Greek and Roman mythology, and they're pretty nasty, I got to say. They're not the kind of things that you don't want to get on any of these people's bad side. So the king and queen decide, we're going to go see an oracle, and the oracle is going to tell us what we can do to deal with this situation, how we can solve things. So they go to an oracle, and the oracle basically says, yeah, you know, nothing you can do. There's no way that you can make King Neptune call off this sea monster unless you do something to show how sorry you are, something really, really major, something like, you know, like giving up your daughter to the sea monster or something like that. And of course, that was a horrible kind of situation. But the oracle told them that that was the only thing that they could do. There was no other way to deal with this horrible sea monster. And so the couple went back, and they had to basically weigh the safety of their kingdom versus the life of their beautiful daughter Andromeda, who was obviously beloved by them, and they didn't want to deal with that kind of situation. However, luckily, as usually happens in these stories, there was another option. There was another way, because just when things look down, you can always count on a hero to come back. We'll get to the hero next time around, but I want to show you where some of these constellations are in the sky so that you can follow along with our, there we go. with our, getting that properly? Yeah, there we go. Okay. So Cassiopeia we've seen, and she kind of looks like the M. Cepheus, I don't know how that's supposed to look like a king. That sort of square with a triangle attached to it, that's Cepheus the king. Does not look like a king to me at all. Maybe a picture of a drawing of a house or something like that. You get a young kid to draw a picture of a house. That's how I draw a house, actually. Doesn't look at all like what it's named after. But it is very close to Cassiopeia. And the stars, even though they're faint, you can usually see them from inside the city, not too bad. Now, Cetus, the sea monster, is actually right underneath Mars right now. Mars is not always there, but this right now, it's a good pointer. So if you go to look at Mars in the sky, underneath it, there's sort of this angular circle of stars and then a little bit of a trail and then a big body on the bottom right there. I don't know. It kind of looks like a whale with a tail, maybe. It kind of looks like I don't know what it looks like. Again, not really like what they're named after. That's what Cetus is supposed to look like. Yeah, that's what I see, right? Yeah. Anyway, Cetus the sea monster, not nearly as impressive in the sky as he was in mythology. And there's Cassiopeia and Cepheus, the king and queen up there. They're at least high overhead, so you should be able to spot them. What will happen to Princess Andromeda? Will they sacrifice her to the sea monster? Tune in next week and you'll find out the resolution of this particular story. These stories help us relate all the constellations up there. Let's face it, it would be hard to remember all of these constellations if they were just named like serial numbers or something like that. So having these stories sort of connects us to the sky, gives us something to remember as we look at the stars. It'll put certain constellations together. It's just a way for humans to sort of organize the sky, and that works really well. Okay, let's see here. Just make sure that the chat is functioning properly. There we go. Wow. I just reopened the chat and we wind up with something like, oh, look, you've missed 912 messages or something like that. It's just been really active here in Zoom, which is fantastic. Mike, you got any questions or any particular themes that are going on in the chat there?
Oh boy, do we? I mean, there's lots of great things in the chat, lots of great questions. Do you want to stick to the moon ones for now, or what do you want to do?
We're coming to the end of the show, so we can start ranging a little farther afield if you want.
Okay, well, let's cover a couple of the common moon ones that are coming up. We've got a question about how many rovers or landers are currently on the moon.
That's a great question. There's a lot of ones that aren't working anymore. The base of the bottom part of the Apollo landers, there's 6 of them up there. There's a couple of Soviet Lunokhod rovers, which were robotic rovers sent in the 70s. The Chinese rover U2 is still up there. That was just from a couple of years ago, actually. And there's also the base from the most recent Chinese probe. They landed, scooped up some rocks, and then blasted back to the Earth and brought the rocks back. But basically, the bottom half of that spacecraft is still there. And there's probably a whole bunch of other ones. Back in the 50s and 60s, they kind of used the moon for target practice. It's like, well, can we even get stuff off the ground? Can we even get rockets that don't blow up? Well, let's shoot it at the moon. And so if we hit the moon, we'll at least know that we hit something. So there's a bunch of stuff that has hit the moon in over the last 60, 70 years of space exploration. Good question.
Speaking of hitting the moon, some people are fascinated by the craters you were showing there on the lunar surface. Someone was wondering, Bernice was wondering, what sort of size reference can you give for something, say, the size of the city of Winnipeg?
You mean for the craters relative to
the craters on the moon? Yeah, how would they compare to, say, like a city the size of Winnipeg?
Yeah, okay. Well, the craters that you can see in binoculars, most of those are probably 100 kilometers across, so way bigger than the city of Winnipeg. The smaller ones that are only visible in a telescope, in a good-sized telescope, you can see craters down to around 1 kilometer or 2 across would be the tiniest ones that you could see. So from Earth, you just can't see anything smaller than that, not because of the telescope, but actually because of the atmosphere that we have to look through. We live at the bottom of this ocean of air above us, and all the heat waves and all that kind of stuff in the atmosphere distorts the view and sort of makes a practical limit on how much detail we can see. So no, you can't use your telescope and see the footprints on the moon or anything like that. Not because they're not there, but because the atmosphere is in the way.
And we've got one great question from Facebook, Jonah. And this is a question, I was going to look it up myself because I don't know the answer. So let's see if you do. He saw on YouTube that the moon might be hollow, that something crashed into it and it rang like a bell for hours. Is this true?
Well, it's partly. So remember I said we were using the moon for target practice. When the Apollo missions went there, the Apollo rockets were like these gigantic rockets about as tall as the Richardson building in downtown Winnipeg. And almost all of that was just fuel tank. And as they flew along, they would let off pieces of the fuel tank to save weight. The upper stage of that, called the S4B, was like the last thing, the one that took them from the Earth to the moon, basically. And when they were done with it, they just let it go and it crashed into the moon. Well, the first couple of Apollo missions, when they were down on the surface, they left seismographs to listen for moonquakes and any kind of geology and stuff like that. And then later on, the later Apollo missions, when those rockets would crash into the moon, that would be like creating a miniature moonquake that the detectors could hear. So yeah, it was really entertaining to, hear these rockets crash into the moon, because you're basically able to make a moonquake and test your instruments. And the moon did in fact ring and vibrate. Now it's not necessarily because it's hollow, but it actually tells us a little bit about the composition of the moon. If the moon had a liquid magma, like lava core, those vibrations would die out faster. But because the moon is solid all the way through, it's basically, if it had volcanoes down in it, those are all extinct. All the lava has hardened, and so it's very brittle and very solid, and so the whole thing just vibrates without any of that central core to sort of slow down the oscillations. So that did tell us quite a bit about what the moon is made of, and that's why we do those experiments. Not just because it's fun, but also because it can tell us a lot of great scientific information about the moon without having to, dig down to the core of the moon or anything like that. Great question.
Well, there you go. I learned something today myself. That's fantastic. Switching the topics just a little bit. I know we're running a little short on time, but your talk about Artemis and the astronauts that are preparing to head towards the moon have inspired quite a few of our viewers. Someone was asking about, is there a certain age that is restrictive to astronauts? I thought maybe you could talk a little bit about what it takes to be an astronaut. I know many of our viewers are probably inspired by what you're talking about. Let's talk about what they have to do if they want to become one.
Absolutely. Well, astronauts, generally, when you apply to be an astronaut, they want you to have some advanced science or medical or engineering degree. So you have to be a doctor or a scientist or an engineer of some kind. Partly because they need those expertise in the astronaut corps, partly because it also shows that you're willing to work hard and pursue something that you're interested in, and learn as much as you can about it. It sort of shows that you have the right stuff, I guess, to be an astronaut. Canada has asked for applications 4 or 5 times, I think now. And I applied the first 4 times and I did not get in. Although one time I got into the first round, I was really excited about that. They don't have an age limit because I know that because I applied the first time when I was 10, and I also still didn't get in. But generally, I think, especially for these pioneering missions where they're going to places that, with new technology, they're probably going to go with folks that have a whole bunch of experience. They're pilots and they're scuba divers and they're experts in a whole bunch of different science and engineering and things like that. And even if you get selected as an astronaut, That's just the beginning, because then you go into astronaut training. I just saw Bradley was asking, how do you have to train to be an astronaut? Absolutely. That's all you do if you're an astronaut, is you train. You learn new things, you practice spacewalks, you practice all the possible things that might go wrong in your spaceship. You learn about the moon's geology, so you know which rocks are the right ones to pick up. You have to learn about the stars so that you can navigate in case the computers go down. You pretty much have to know everything about everything, because you're going to be out there all by yourself. There's no, you won't be able to just, call CAA for a tow or something like that. You're pretty much going to be on your own. And so they really want those folks to have all the possible advantages. You also have to be really, really physically fit, because let's face it, wearing a big space suit and doing that kind of stuff requires a pretty healthy person. So you should exercise, and you should do science and math. Those will be the things that'll help you be ready to be an astronaut.
Yeah, that's
Okay.
amazing. And somebody was asking, would you like to be an astronaut? I mean, I'm going to pipe up and say I'd love to be an astronaut personally. I'm thinking that answer is yes for you, right, Scott?
Yeah, well, I didn't apply the last time, because now I have a couple of kids, and they were sort of like, "Oh, Dad, we don't want you to go into space." It's like, okay, well, fine, I won't apply. I probably wouldn't have got in anyway. But I think, though, that space travel, especially with all these new companies doing things, space travel is starting to develop kind of like airplanes were. I mean, when airplanes first came out, only a few people had them, and you couldn't just buy a ticket on an airplane. But then companies got involved, and suddenly there was more access, and eventually the price went down. And I mean, up until things shut down for COVID, you could buy an airplane ticket for a couple $100 and get on an airplane and fly. And people stopped thinking about the airplane as the big deal, and it just became a way to get somewhere else. Well, space travel is going to do the same things. But in the next 20 years, I hope you'll be able to buy a ticket to at least go up into Earth orbit and see what the Earth looks like from space, because I think that's a life-changing activity that everybody should have.
Well, like I say, I think we've inspired many of our viewers here on Zoom and on Facebook. Bradley says, I'm going to be an astronaut when I grow up. That's amazing to hear. And Scott, I have to say, I'm kind of glad that you didn't apply to be an astronaut and get to go, because then we wouldn't get to hear you talk and share your enthusiasm about space and astronomy. So we're thankful of that part, at least. But just keeping track of the time here, I think we probably want to start to wrap things up. I just want to say to some of our viewers on both Zoom and Facebook, I'm sorry we didn't get to everybody's questions, but there are a lot of questions that are about topics coming up in future episodes. So stay tuned, come to other episodes, and we'll hopefully be able to answer your questions then.
Yeah, absolutely. And if you got something that just can't wait, remember space@manitobamuseum.ca, and we'll try and get to them as well. Thank you all for coming out. It's been a lot of fun. I love the group of folks that are coming out here. Oh yeah, what's next week? That's a great question. Next week we will be finishing up our legend of Cassiopeia and so on, finding a few more constellations. We'll also be looking at the planet Mercury, which will be visible briefly for a week or so. We're going to talk about the International Space Station, which is going to be coming over, and probably a few other surprises as well. So tune in next week. Again, it's always Thursday at 7 o'clock. Register to get in on the Zoom chat here. That's where a lot of the activity is going on. We also stream live to Facebook, of course. Thanks again for coming, everyone, and we will see you all next week. Have a great week and clear skies.